So let's welcome Vanshika Agarwal. She is a software engineer at Google. Hi Vanshika, how are you?
Hi, I'm good. How are you?
I'm good too. So Vanshika is here for a mock interview with us. We'll be having a system design mock interview. And Vanshika, today I want you to design Leetcode.
Okay. So I'll just type out the title first, and then we can sort of discuss some functional requirements, and then move on to the non-functional requirements, and so on. Does that work with you?
Yeah, that works. And let me also explain to my viewers if they don't know Leetcode. But to be honest, Leetcode doesn't need any introduction. And you might be already spending a lot of time there practicing coding interviews for your system design. And Leetcode is majorly for software engineers. And we do prepare all DSA, mostly DSA questions there. And Vanshika, you can proceed.
Okay. So firstly, I'll start with the functional requirements. We can sort of discuss them one by one in case there are any miscommunications or if we need to discuss further on certain requirements. So I think the first requirement would be that we are able to view a list of coding problems.
Right.
The second one could be that we will view like a given problem and we can code a solution using any language of our choice.
Yeah.
So I can just say view a given problem and code solution in any language
of their choice. Yeah, that's perfect.
The third one could be that we can submit the solution and we can get instant feedback, like how we get it on Leetcode, whether our code has passed all the test cases, is it failing, and so on.
Yeah. Mm.
So actually, I was thinking of some out of scope requirements also. Like we can decide if we want to keep all of them as out of scope or we can put some of them in our scope. So one could be that we have some authorizations and profile creations in our Leetcode. Also, if we want to start like a premium service in the original Leetcode, we could have some payment gateway also associated.
Yeah,
We can
I think for now we can skip those. But one more requirement that I want you to discuss is that our Leetcode contest that happens bi-weekly and weekly, and that is one of the very popular feature of Leetcode, right? Which are
Yes.
Leetcode contests. So I would want you to also design a live leaderboard for those competitions.
Okay, sir. Live leaderboard for Leetcode BG/bi-weekly.
Correct. Yeah.
Yes. So does this look okay to you?
Yeah. Now it's perfect.
Okay.
And we can assume that we don't need any kind of authentication. We can always assume that user is already pre-logged in, and we don't need to care about the profiles and the payments, and we can skip all those and just focus on these functional requirements.
Sure. So actually, sometimes I also think about writing them as out of scope requirements. But do you want me to
Feel free to do that. Yeah.
Okay, I'll write it as out of scope requirements so that we are on the same page.
Works. Authentication and authorization, user profiles, you can skip.
Yes. Second is payment.
Yeah.
Gateway for paying, so to say. And another one could be if we need to have analytics of each and every user associated with that profile, we can add that.
Yeah, let's skip that. We don't need those.
Okay. I'll just add it as out of scope. I think this looks okay to me. We can move to non-functional requirement if you also feel this is okay.
Sure. Yeah, Vanshika, let's discuss now the non-functional requirements.
Sure. So I'll just write some of the non-functional requirements. So off the top of my head, the first thing that I can think of is whether we want to have a very available system, like it should be highly available, or is it okay if the service goes down? So in my opinion, personally, it's better that the system is always available. We can go for an eventual consistency model.
Okay. So when you say eventual consistency, I mean, you're saying you will put more weightage availability over consistency. So when you say consistency, what exactly in the system you are saying is okay to have eventual consistency?
So one thing that could be okay to have eventual consistency is that if it takes more time for submission of the code to get the instant feedback, So that is okay, but the service should not be down. Like all the test cases, if we do not get the answer for all the test cases instantly, but the service is available at all times, that is more important than us getting the exact correct answer on all the nodes associated with it.
Okay, it sounds more like of that you want a low latency platform that you still get the answer quicker, maybe less than in a second or 2 second, max 5 second. You can have a time limit, but
Yes.
you want that system is available irrespective of that two users are seeing two different submission results for the same test cases or for the same code, or is it like one user might see 1,000 problems on the problem list and one user might see just 10 less or maybe 990 problems?
Yes. So actually, it doesn't. According to me, for Leetcode, it's more important that the website is available at all times, but the number of people or the number of people seeing the number of submissions or the number of questions at a given time could vary by say plus minus 10, for example.
I mean, yeah, that could be eventually consistent. Let's say any new problem as it added, some user might be seeing it or some might not be seeing, depending on the deployment in the region or it's global.
Got it.
It's fine. Good for me.
One other thing that I can think of is that there should be some sort of security or isolation when it comes to the code that is being run by a user, so that it does not really affect the overall system. In the sense that if anyone wants to put in some malware while trying to run code on our terminal on Leetcode, they could eventually take down the whole service. So we want to keep that, like some isolation should be there, and there are some security features also available so that the service does not go down. Does that make sense?
Yeah. So if I'm getting it correctly, you are saying that whenever user or the client of Leetcode tries to submit their code, and when we actually run those against our test cases, we have to make sure that each code is isolated and it does not disturb the other submissions, and it doesn't affect our current system, right?
Correct.
Yeah. Okay. Sounds good. Yeah.
Or code. It's better to use of user code.
Yeah. Perfect. We can just keep the point of the notes that we are making. We don't have to be very verbose. Yeah.
Sure. And obviously, the system has to be low latency, so we can have that also as a requirement. Like all of the submission results should be under, say, 2 seconds or 5 seconds.
Yeah, definitely we want a low latency system, and we can discuss later like how much time that we want to cap it. I mean, we do see a lot of time limit exceeded, so we will dive deep later into that part, like when we want to halt the long running operations.
Sure. I will just write maybe less than X seconds, and we can discuss X later on.
Perfect.
So one other thing that I can think of is that I would want to understand how many users do we want to support here. So if the number of users is a lot, we can sort of try to develop a more scalable system or a scalable solution, so that
Definitely, yeah.
because of the bi-week, I'm sorry.
Yeah, please go.
Yeah. So because of the bi-weekly and weekly contests, I think during those times there may be a surge of active users. So maybe we can assume an order of users, maybe 100,000 or 10,000, depending on.
Yeah, I mean, overall, we would say the monthly active or daily active users could be in million, like hundreds of millions. But if we're just talking about the Leetcode contest, having 100K users or 50K users actively, like currently actively giving contest is fine. But overall, the system should be scalable to support millions of users, like millions of daily active users or monthly active users.
Scalable to support million of.
Because in general, Leetcode sees 1 million active users per day and hundreds of millions active users per month.
Yes, but I think, in my opinion, during competitions is one time wherein so a lot of people passively also use Leetcode, as in they'll look at a question, maybe come and submit it later on, and so on. And there's no time foundation as such, right? But during competitions, a lot of people would actually just be using or accessing the same set of problems.
I mean, yeah, I mean, I get it. So you're trying to say that number of concurrent users would be really, really high during contest. And other than that period of time will have low QPS as compared to the contest duration. Yeah,
Yes.
we'll talk about that time, like how we can scale up our systems to meet that kind of search data.
I'm just adding it as a sub point to our earlier scalability
Go ahead.
requirement. So scale to support petition users. I'm just using autocorrect so that the process is faster.
No worries. You can just write the pointers. Don't need to be very verbose. Yeah.
Then we can move on to some other things that I can think of that might or might not be in our scope right now.
Okay.
I think the system should be fault tolerant as much as possible.
Okay.
And if required, we can keep some sort of backups as well of the submissions. We can decide that we need backups of say up to 5 years or 2 years and so on.
Yeah, I think we can skip those kind of discussions if we have time left by the end of interview. We can. You can keep it as an auto scope. And also, you said that system should be fault tolerant as much as possible. What do you mean by that?
I mean that no single server or node of our system should result in being the only source of problems. Like if all of the queries are being routed to one particular server in our system, so to say, and if that server goes down, then we will like the result would be that none of the queries are being returned because all of the queries were being routed to that particular server.
Yeah.
So we want to have like a distributed system architecture so that there's no single point of failure, for example.
I get it. So in a distributed kind of network, you want to avoid single point of failures. You want to have multiple nodes and some sort of consistent hashing so that if one node goes down, we'll have the other nodes alive taking the traffic.
Correct.
Yeah. Perfect. Cool. We can move forward.
So, so the next thing that I can think of is of discussing some entities like the core entities for our system. So one of them would be the problem. The second one could be the user.
Okay.
The third one, I'll just refer to my functional requirements again, could be the solution of the problem. And lastly, since we have a live leaderboard to cater to, we would also need a leaderboard as our core entity.
Okay.
So,
also, we can safely assume or consider the current Leetcode architecture, which has around 4,000 to 5,000 problems overall, and not just the DSA ones, like considering all of the problems, and a million user.
Okay.
Yeah.
I'll keep that in mind.
Yeah, sure.
So the next thing that I can think of is writing the API routes for our system. So whatever queries, so I'll be using RESTful API queries here, RESTful API endpoints, and I'll just discuss it in short, and then we can sort of figure out if we need to write anything else as well.
Sure.
So the first thing is that we would want to get the list of the problems that are available. We could also allow some filtering to those problems, or we can display the whole page. Depending on that, we can have like a GET request to our server. So get a list of problems. So we could have like problems. And I'm just assuming that we have some filters and limits assigned to the particular set of problems or list of problems, so to say. Is that okay?
Yeah, that's okay.
Okay, so maybe the limit could be say 100. We can display the first 100 problems. Age will be equal to 1 and the limit will be equal to 100. Yeah, I think.
Any specific reason behind using like the default size?
Yeah, so the first page.
First of all, why do you want this to be paginated? Since we only have 4,000 problems, right? Do we really need pagination here?
I think it's better that we have pagination so that not all of the problems will be displayed on the same page. So it's better to use pagination in my opinion, because the number of problems is not very less. If the problems were say 200, then also I think pagination is not that. But if the number of pages, if the number of problems are more or in the order of thousands, I think it's always better to use pagination.
Okay, sounds good.
So we could have like a partial. So yeah, the syntax of this could be better. I could go with the original syntax as well, but if this works, then that's also fine.
Yeah, completely fine.
Okay. So yeah, we sort of viewed the problems. Now the other thing that I can think of is that we can also view some specific problems. Like we can have a filter, so to say. So or like that filter could be related to say company specific or language specific and so on. Does that make sense?
I mean, one is that you'll have a REST endpoint to get all the problems, like which is simple
Yeah.
get all. And now you're speaking about getting problem via ID, right?
Yes,
Like,
correct.
okay. I mean, when the users clicked on a problem statement and then the description, the constraints, the sample input test cases, all the metadata of that problem ID should be written in that.
Uh, yes, and we could also have another like a get API endpoint to filter the problems. So that would be pretty similar to this one. We would just need to add some filtrations as well.
Yeah,
So,
man, you try to say, right?
yeah.
We can filter by the category of difficulty, like easy, medium, hard. And
Yes.
if it is, let's say you want to just see the problem based on the number of submissions, some sort of things. Yeah, we can have those kind of filters.
Yeah, so that would be taken care of by the first get request only, or we could have a separate endpoint for that, but I don't think that's necessary at the moment.
Works. We can move forward.
Now we can like view just a specific problem. So for that also we would need like a get endpoint. We will just go to the problems and the problem ID, like I'll be using a problem ID for each of the particular problem that we have. And then we could have like a language filter that this is the language in which that person is coding, so to say, or this is the language we expect the answer in. So that's a language filter that we can add. Does that make sense?
Makes sense. Any other kind of filters that you could possibly add other than just language?
Another filter, so for a specific problem that we could add is that we could add some tags wherein it could say that this is a DSA problem, this is an LLP problem, and so on.
Okay. So that is for getting the list of problems, right? I was talking about you specifically had this language filter for problems, like get problem by ID. What's the rationale behind that?
So if we want to submit a particular problem, the user will be writing the code in a particular language. So it is essential that we have at least a language filter for that particular problem. Other than that, inside of our specific problem, I don't think we need any other filter. Like the other filters would be for our list of problems, but inside a specific problem, I think language is the only filter that I can think of. If you differ, then I could sort of think about.
I wanted to ask why language, like what benefit it's giving you, like
So
what if you don't mention language?
Then we don't know which node or compiler we would want to route this particular request to, because not all of the architecture that I am thinking of currently would look like that. For a particular language, we would have a particular server or node, for example. And
I get it. You answered it correctly. So we would like to have a problem associated with multiple languages. So let's say if user selects Python, then all the formatting, like formatter client and the template client, let's say you must see, right, the template part of it. Once we select the languages, we get different templates of the functions that we want to implement. And yeah, the compiler client, all those kind of things, we want to have it. So yeah, that's correct.
Okay. Then lastly, not lastly, so we need to submit a problem also. I'll decide if this is the last endpoint or not after this. So we would have like a post request for this.
Okay.
And then we would have the problems. We also need the ID associated, and then we need to submit the problem, so to say. So we will have like the submission, and then so the code would be a string, and the language would also be string. Yeah, I think.
I want to fret upon this. Are you planning to pass the complete code as a string to your server?
Yeah. So we can pass it as a string so that it's simpler and it becomes language agnostic. So we don't really care much about the language then.
Okay.
But obviously, I think we can encode and encrypt whatever code is being submitted, and then later on decode it at the compiler side of things. But like right now, I think we can start with this as a base point, so to say, and then we can take it forward.
Yeah, sounds good. You can move.
Okay. So yeah, I think these are some of the API routes that I can think of. One other thing that is left is for the leaderboard, or like the competition live leaderboard.
Okay.
So we need to get the leaderboard, so to say. So for this as well, we will have a get request. So we could have like a competition ID for this.
Mhm.
And we can paginate this as well, so that we are displaying a limited number of leaders on a particular page.
Yeah, sounds good.
We can always change the limits. For now, I'm just keeping 100 as the limit. Yeah, I think that's about it for API endpoints or API routes. If I think of anything else later on, we can sort of just get back here.
Sure.
Okay, so after this, I'll just start. So with each of the functional requirements, I'll put in the most basic high-level design that I can think of. I'll circle back to it to sort of make some improvements, and we can discuss as in that required. Does that sound okay?
Yeah, sounds good.
Okay, so for the first, we have that we need to view a list of coding problems.
Okay.
So I think we'll have a client who will like send a get request, and then we can also have like an API server for this. And then we also need to have like a database so that we can store all of the entries, so to say. Does that sound okay to you?
Yeah.
And all of these would be bidirectional, because we need to get a problem also, and sometimes we need to submit a problem also.
Okay.
Hmm. So yeah, the schema of our database right now could look like we could have like a problem with an associated ID, description, so to say, and we can also have some stats probably, or on how many submissions have been done, for example. And we could also have some test cases. And I think that's about it. And any other metadata is required.
Okay. And for now, we can just keep a minimal list of
Sure.
attributes that we want to store.
Okay.
So what kind of database you will choose to store these data?
So I was thinking of DynamoDB as a database of choice. Like, we don't really need a SQL database in this case, or a relational database, because there are not a lot of relations that are really there. And DynamoDB will give us the option that we can expand a lot in the future as well. So that's one thing that I'm thinking of. We don't even need any joins or anything here. So an RDBMS doesn't make much sense. Although both sorts of database nowadays offer features of the other, like NoSQL and SQL offer features of each other also. But I think in this case we can go with that DynamoDB.
Okay. I think DynamoDB, yeah, it's a NoSQL database. So no, it's a NoSQL database, and the choice would be having a flexibility of schema, right, that you want to have. Is it the primary reason?
One is the flexibility of the schema, and the second thing is that in general, I tend to use relational databases when we have evident relations that we would need, or when we are sure that we would need to query the database in such a way that we would sort of need to join multiple different tables for any reason, so to say. But both of these use cases do not seem to be applicable for our set of requirements. So that's why I was thinking that we can use DynamoDB.
Okay, sounds good.
Okay, so I think now we can move to next. So we have covered list of coding problems and view a given problem. One other thing that I can actually think about NoSQL is that we can have everything as a single document. Like, we can have nested test cases as well. So that's one advantage as well that we are getting over SQL databases. Does that make sense?
Yeah.
Okay, so now we need to view a given problem and code the solution. So for that, we could have, like, I think our current structure already handles most of it. So we will have like a client for the in-browser coding. And the flow would be that we would fetch a problem by the ID and we would like sort of display the problem, and then the user can just code the solution.
Okay.
With respect to submission of the solution and getting instant feedback, again, the core of this would be that the user needs to execute the code safely, both for the user as well as for the system. So and we sort of get the result, like whether it is failing, it's passing, or is there any sort of an error. So one thing that I can think of is that we can run the code directly on our API server. But it's not a very good solution, or I think it's a very bad solution because the first thing that comes to my mind is it's a very huge security risk. So if any user sort of has any malintentions with respect to our problem, they could plant some sort of malware in their submission, and all of our data could potentially be deleted, or we could also face some DDoS attacks, like a lot of queries come in our server again and again just so that we shut down, so to say. The second problem with this approach is that it could lead to a lot of CPU or memory hog, so to say. And lastly, since there is no isolation and no fault tolerance as well, if our API server will crash, then it would result in a lot of downtime for our system. So a better solution would be, as I mentioned before also, I think that we sort of have isolated nodes wherein we can have the execution. So we could have some VM based execution where there is a good isolation, and it's the possibility of crashes is lower than the initial approach that I had suggested of API servers. So, but the problem with this could be that it would be very heavy for our system, like because all of the VMs, they need their separate memory and CPU usage. So it could increase the complexity of our system. But like in my opinion, this is better than running everything on our API server, but this could lead to some inefficiencies.
What kind of inefficiencies?
The one inefficiency that I can think of is that a lot of resource hogging would be done in this case, because every VM has their own memory, has their own compute capacity. So this is like sort of wasteful usage of compute resources. We are not really, this complexity is not really required, because we can actually move to some other container-based approaches nowadays. They don't need their own memory and compute resources, as far as I understand. It's just a lightweight Docker image or something that we can use. The other thing with the VM-based approach is that it will become very costly for us because VMs in general are pretty costly. So,
I mean, costly in terms of
amount, like the amount that we are spending to set up this architecture, and sort of the cost to usage ratio, because we need to.
I mean, like you're saying the maintenance cost would be high. So VMs comes with its own operating system, and in general, they are more heavier than as compared to the containers. We are choosing containers over VMs. Is that the reason?
Yes.
Okay. What do you mean by containers? Like, as in, have you ever used any container previously, like Kubernetes?
Docker images can be used in this case. I have used it very briefly in my internship at Oracle, but not extensively. So they are like very lightweight, since they do not have the associated memory and operating system. And they're generally used for end-to-end deployment of features, which often carry a significant weight of problems, like if the environment changes for a particular service, then it becomes difficult to deploy them in different environments. So with Docker, the environment is set up in that particular image itself, and we just need to deploy it on our system. So it becomes quite easy. Like there is good isolation when it comes to the process. So we can use that. And for each of the languages that we are using, we can have like one container for that particular language. Like, does that make sense?
I mean, isolation you can get more better in VMs as compared to containers. I mean, container itself carry shared spaces from their host machine. They don't have their own dedicated, because they don't have their own dedicated operating system. They don't have their dedicated memory. They are like sort of shared spaces. And isolation, if you're talking about isolation, I think VM will give you more better isolation as compared to containers. But what I can get from you is that containers might be giving you better like resource utilization in general, and better flexibility of turning up and turning them down, like scaling them up and scaling them down based on our needs. And we have those kind of services available in both GCP and AWS, like Elastic Container Services like ECS, EKS.
Yes.
And it's more familiar like Kubernetes, one of them developed by Google. Yeah, that makes sense.
So just to add on this, I think with the containerization, we could have better process level isolation, like because we are using shared kernels in containers. So I didn't mean isolation per se, but for a particular process, there might be better isolation in containers.
Okay.
Using containers.
Okay. So are you also planning to use these like same container for running multiple processes, or just one process per container? Like
yeah, one container per runtime.
I mean, you might be running multiple submissions or multiple result check in a single container, right? Otherwise, again, you're wasting enough resources if you're having a container. Let's say you can have container per language wise. Let's say you have one container for Python, one container for, and you have some n number of jobs running within that container.
So yeah, when I mean runtime, what I mean is that for a particular problem, if a particular user is submitting their like code, for example, then for each of the languages that they have, all of those like associated queries would be routed to that particular container. So one could be like we have a language-based runtime as well, and inside of each of those runtimes, we could also have process-based runtimes in the sense that for each problem, we have a different scope that we are dealing with. Does that make sense?
That makes sense, but I think overall using containers for this kind of thing would be challenging. You would need a lot of optimization and configuration, and security concerns are also there. My take would be, why don't you consider using a serverless architecture?
A serverless architecture.
I mean, are you aware of Google Cloud Functions, AWS Lambda?
So I have heard about it, but I haven't used them actively. Okay. So I'm not sure how we would go on about implementing the same.
Okay, that's completely fine. We can move ahead with the containerization of this.
So I'm just making two of them, but you understand that we will be using different runtimes for different languages, right?
Yeah.
So we can now move on to the non-functional requirements. But so for the live leaderboard, for the Leetcode weekly and bi-weekly contests, I think our current architecture also works. I don't think that there should be any problem with catering to the live leaderboard as well. Like we could just introduce another schema here wherein we have details about the submissions, and then the associated leaders can be like we could have another list of leaderboard, like in the primary database we could have another schema for that. Does that make sense?
Okay, I would like to see that schema.
Sure. So first I'll also add the schema for the submissions. So for the submissions also, I think we'll have an ID. We'll for the leaderboard we need the submission, so we could have a competition ID that is associated for that particular contest, so to say. Does that make sense?
Yeah.
Then we could also have like a timestamp, because the faster you complete something, the better rank you get on the leaderboard.
Okay.
So submitted app. Another thing could be the test case result, whether it's passing, failing or not, and so on. Then we could also have like a runtime, the associated runtime that we get on Leetcode, like how many seconds it took for a code to run, so to say. And then we could have any error statuses as well. Then for the leaderboard, I think we could just have like a query wherein we see the submitted at the test case result at runtime and errors, and have like a query which could just fetch those results. So I don't think we need a we need another schema for the same. Like, do you agree with this?
What would the query look like? I'm not able to picturize it.
Basically, based on some filters, like for example, the ID, the competition ID, and whatever so for a particular competition ID, we could query based on the submitted times as well as filtering based on the results. So only past results would be accepted, and then if required, we could have further filtering based on runtime and errors. So and the number of times we sort of ran our code on the machine or clicked submit button, so to say.
Okay.
So does that make sense?
Yeah, makes sense.
Okay. So and then like this competition ID could be like our partition key for this case.
Why would we need a partition key here?
Because
Why not the submission ID?
sorry.
Why not the submission ID?
So there could be multiple submissions for a particular problem, but for a particular competition, we need to keep only those IDs in our mind when we are sort of fetching all the submissions and aggregating and sorting them. So submission ID doesn't make sense for that. We need it only for a particular competition. So it would make more sense to use.
I mean, you're trying to say that we would like to index our submission table on competition ID so that the lookup is faster for any particular competition.
Yes. Yeah.
Sounds good. Yeah. Because we'll have limited number of competition as compared to this number of submissions.
Yes, and submission IDs could also be for like we would have information that we don't really need when we query submission IDs. So if a person has solved the question say faster than anyone else, but they were not competing in a competition, they were just solving it for practice or something like that, then that result is essentially redundant for us. We don't need that information, so why would we want to use it? Like we can't even use it actually because we just want it for our competition. Does that make sense to you?
Yeah, that makes sense. I think there's a missing piece of information in the submission table. Submission table is that how would we like reverse map it with the user ID, like whose submission it belongs to. I think we don't see a user ID in the submission table.
Yeah, we can add that.
Okay.
So yeah, I think that's about it. So when it comes to should I tell you the end-to-end flow as of now once, and then we can move to the non-functional requirements?
Sure.
So basically, especially for the live leaderboard, like the client will sort of just query the leaderboard for a particular competition ID. Then we would have an API which will check all of the query submissions, so to say. Another API which can just aggregate and rank the users, which was about the query that I was talking about earlier. And then we could have like an API to return the leaderboard. And then the client can just refetch it periodically depending on the duration of our competition.
I mean, we don't need multiple APIs for all those stuff. We can have just one single API which runs the query, which queries the table with a particular SQL query. Could be like select me all, like give me all the submissions for this competition ID, and then you can group by the user IDs, and then you can group by the the submission.
Yes,
successive submissions.
We can have like a common API also for this, or if required, we can split it into two as well, depending on how much.
Yeah, I mean the overall query we can always talk about. We can debate about the efficiency of it because it's a good start. We can optimize later in a deep.
Sure. So 1 second, sorry. So moving on to our non-functional requirements. So we will be choosing availability over consistency and isolation and security of the user code, so to say. So the first thing for availability, I think what we can do, so for security and isolation, what we can do is that we can make sure that the containers, we write all of the output into like a temporary directory, and that can be like cleaned periodically depending on the time that we decide or the number of users that are actually sort of submitting code. So that can always be calculated later on. And when it comes to timeout, like we can have like a timeout. So the TLE error that we often get, we could have like a capping on the TLE. So earlier, I think we were discussing we could have like 2 seconds or 5 seconds. So we could have like a timeout for that. And then it will help us to stop infinite loops and further ensure the security of running the user code.
Okay.
So the next thing that we had mentioned is like we need to support the computation users of up to 100K, like we need to have some scaling and we need low latency to return the submission results. So for all of this, I think the first thing that comes to my mind is that we can poll our database specifically for the leadership or the leaderboard fetching. We can just keep on polling our database every 5 seconds or 10 seconds, depending on how frequently we want to check the newest leader, so to say.
Okay.
But then, this has a lot of drawbacks essentially around database load, and it would have very high latency, and it cannot be scaled for large contests wherein a lot of users are joining. So the better thing to do is that we could have like a cache, and that will just periodically compute the leaderboard and just store it somewhere. Like we can just store it in the cache, so to say, and then those reads can be first chosen. So this will result in some database load reduction. But the problem with this is that it's not really real time, and essentially we are just still querying the database.
Okay.
So that's one thing that could lead to.
Yeah, I think caching is a promising solution. I won't go into the details of how to implement caching, but yeah, it's a good point of start that we can obviously have a caching for a running contest, and so that we don't overload or throttle our databases, querying every 5 seconds or let's say second, which would be so much of resource.
Correct.
Yeah.
I'll just move some parts of this so that we have more space to work with.
I would also like you to talk about how we could scale it for 100K users or million users.
Sure. Algorithm, just draw the cache first and then we can move to scaling. Is that okay?
Yeah.
So for cache, we can use Redis or whatever the preferred
It's fine.
cache for a particular use.
We don't need to fret upon it, what caching framework we are using, it's fine. We can also have any memory.
Yeah.
Yeah, rather than having a distributed cache.
Yeah, we can do that as well. So yeah, to support like 100K users during contests or in general to have like a scalable system, the one thing that I can think of is first is we can obviously always scale vertically. Can have bigger machines, bigger CPUs and memories. Like nowadays, a lot of computer sources have like a lot of computational power, but this is not really a long-term solution because obviously if the number of users keeps increasing, just adding capacity and throwing capacity will not help anyone. So the better solution would be to horizontally scale the system. Like we can have multiple servers horizontally, and for each of the languages, we can have some specific containers, and that could also be scaled further. So instead of one runtime service, we could have like n number of runtime services depending on the number of users that we are expecting. So for millions of users, I think 3-4 servers should do it. And we can obviously have a more realistic calculations depending on the exact numbers of a particular service. So for that, we can always scale it horizontally. Then another thing, while like that we can keep in mind. So for horizontal scaling, one other thing that I can think of is that like we can use a queue as well, like between the API server and the containers. So this can help in better sort of routing, and it would result in lesser significant traffic spikes that could lead to a lot of unnecessary traffic, so to say. Like, so workers can, like these runtime servers or these services, they can just pull some the jobs and execute it and update the database and the cache accordingly. So it'll help to smoothen out the traffic spikes, so to say. So does that make sense?
Yeah, that makes sense.
And we could also add some sort of retry mechanisms. Like if the containers fail for some submissions, we could have some exponential retry mechanisms as well. So that after each failed attempt, after some time, we could have like another attempt, and the timings between those attempts could sort of increase with each retry. So, yeah, I think that is one thing which we can do. Apart from that, we can just run the test across different languages. And, yeah, I think that would be about it. Like I can just make those changes in our diagram.
Yeah, it's fine. We can keep it as it is. I would also like to understand how will you be planning to run test cases across multiple languages?
Okay.
So are you planning to have different test cases for different languages because they deal with different data structures. So data structure, let's say tree in Java or then tree in Python would have different implementation, different objects altogether. So what's your plan around that?
So in my opinion, the implementation definitely changes, but we have to run essentially the same tests across different languages. So we could have like some standard test cases, so to say. So they will have like a test case definition for each and every problem, and the input and output could be sort of like some metadata, or they could be in JSON, for example.
Okay.
So this way, for each language, we could have some serialization or deserialization that would help to convert for that particular language's use case. So like C++ has hash map and Python has dictionary and so on.
Okay.
But essentially, the core problem would remain the same, right? So it doesn't make sense to have different test cases for different languages. So like we could just serialize a particular input array and then have some deserializer for a particular language and so on.
Makes sense. Makes sense. Good. So that was all, Vanshika, that I had for you. Do you have any final note that you want to make, any change in the diagram or anything that you want to discuss?
Yeah, so one thing that I wanted to discuss is that we would not want to have like a single database. We could have like a distributed database, in the sense that we have a master slave architecture wherein the particular database has some slaves or replicas. And in case this primary database goes down, we can promote either of the replicas to the master so that it doesn't result into like a single point of failure. And for scaling also, this is a good solution. And that is one thing that I would like to add.
And this is for problems database or submissions?
Both of the databases we can do the same for both of the databases, but for the problems database, I don't think we require it because we have a limited number of problems. I think only 4,000. Yeah. So if in the future we are dealing with hundreds of thousands of problems, then definitely we could try that, but currently it's not required. But for the submissions database, it is definitely required.
Thank you so much, Vanshika.
Thank you.
It was a great system design mock interview. Thanks for taking out time for us. And if you have any final note for the viewers that you want to suggest, maybe something from your journey, your preparation journey, or interview experience that you want to share?
So actually, I haven't given many system design interviews, or I think I haven't given any system design interview. I have just given some mock system design interviews. And so for the final interview, I wouldn't have much thoughts for the viewers. But one resource actually that I would like to call out here is Hello Interview. So I've been following their page, blog, website, whatever you want to call it, for quite some time. And they have really interesting reads for both kinds of people, like the kind of people who are generally interested in design and the kind of people who are only interested in design because they have an interview coming up, so to say. So they have incredible videos also, and their blogs are very good. Another resource that I found very helpful for design interviews was the YouTube channel by Shreyans Jain. So in case anyone is interested, they can check it out. So that's something that kind of helped me. And please share your views with me as well if you have any other architecture or HLDs in mind with respect to Leetcode or any feedback.
And yeah, I would appreciate you for sharing your honest resources that you're preparing from. And I would resonate on that Hello Interview. I got an offer, software engineering, and GKCS. Shreyans, I haven't seen his videos, Shreyans Jain. But I think these are some promising resources that you can follow. I'm also trying to come up with system design videos specifically for interview preparation. It's in the pipeline. But yeah, thanks for being honest.
Sure. Thank you.
Yeah, thanks so much, Vanshika.